Good day, class. Today we're going to attempt a practical regarding enthalpy change for the decomposition of calcium hydroxide. So I will briefly show up a picture right here, so you can see the reaction itself. It's the thermal decomposition of calcium hydroxide becoming calcium oxide and water. Unfortunately, to do the actual enthalpy change measurement, it will be pretty difficult. Instead, we are going to do two reactions: calcium hydroxide solid with HCl, and we'll measure the energy change there, convert it to an enthalpy change. We will repeat the same experiment with calcium oxide. By right, students who are attempting this practical will need to have quite solid knowledge on enthalpy change and a Hess cycle. Now the procedure is as given for now. So first we have to support a plastic cup in a 250 cm cube beaker. So let me get the equipment. Okay, so plastic cup. Let's insert it in the beaker that will support it. Pull this out of the way. And here I have a solution of FB6 which contains hydrochloric acid. I will need a measuring cylinder to measure out 40.0 cm cube. And finally, I'll need a thermometer to measure the temperature change. So 40 cm cube measuring cylinder, thermometer. I'll need to measure out 40 cm cube of FB6. Okay, so that's 40 cm cube of FB6, which supposedly contains HCl, even though it's a bit yellow. That's probably due to some impurities in it, but I've tested the solution. It does have the correct 2.5 molar HCl. So that will go in our plastic cup. And just to normalize the conditions, I will measure the temperature. At 25.0 degrees Celsius. So I will note this in my table. I've already actually done this experiment. So next part, I have to use my FB4. And because this solid was given to me inside a stoppered tube, I have to take the mass. Now be very careful here. If you're taking the mass of only the unstoppered tube, you have to take the mass of the empty unstoppered tube as well. So some students may take the mass with the lid. If you do it that way, after you transfer the solid into the plastic cup, you will have to weigh the empty stoppered tube as well, so with the stopper. So I'm going to do it without. And my mass is 15.4 grams. I'm going to pour everything in and stir it with my thermometer here. So let's look at the temperature change. It's still rising. Still rising. Avoid holding the thermometer at the very middle. Okay, still rising a little bit. It's going to peak at 43. Check. All the solids gone. Verify. Yep, 43 degrees Celsius. So that should go into your measurements on the table. Now after that, you can remove this. You have to weigh the empty tube without the stopper. I did it without the stopper just now, so it's without the stopper now. 13.4. So I have 15.5 minus 13.4, and you can just put it in the table and calculate the actual mass. Yeah. 2.1 grams of the FB4 being used for this. Okay, so that's for experiment 2A. Then there are some calculations which we'll go through in a separate tutorial. Now in experiment 2B, I have to do the same thing, but instead of using FB4, I will use FB5 instead. So let me just wash my solution first. Be right back. Now for FB5 and FB6. So FB5 is the calcium oxide of a given mass, and we will have to react it with FB6, same thing. So I'm going to have to refill this to 40 cm cube of FB6. Check for Polarex error. Great. Oh, very lucky there. If ever you need to top it up to exactly 40 if you want, you can use a little dropper, yeah, a 1 cm cube pipette. Just drop the solution there to get it to 40. Once you're done, pour it in there. Yeah, try not to lose anything. And measure the temperature again. So it's still the same, 25.0 cm cube. Now I'll have to measure the mass of FP5 without the stopper. So I'm going to do it without a stopper for both measurements. (14.8) is the reading here. Oh, sorry, 14.9 is the reading. Pour it all in. Oof, it's a audible reaction as well. There's some left here, but it's okay. Stir it with the thermometer. Temperature went up to 31, 32, 33, still rising. Oops, looks like it stopped there. 34, let's do some solid dissolving. Barely 35. Is it going up anymore? Nope, that's it. So 35 degrees Celsius from 25. There's a 10 degrees Celsius difference there. So record this in the table, and you will have a set of values. Oh, just to verify. 13.5, so I have to subtract that to get the mass, which is again about 2.0 grams. 2.0 grams. Okay, so that's the experimental procedure part of this question. Unfortunately, this part of the question, including drawing the tables, will net you about 6 marks. So drawing the table boxed in with the correct variables, units labeled, will net you 6 marks total for 2A part 1 and 2B part 1. However, this entire question is worth 14 marks. It's 14 marks total. And out of the 14 marks, the remainder of the 8 marks there, 7 marks come from calculations. And 1 mark comes from an evaluation type question. So yeah, the calculations are very heavy in this question here. Maybe it's 6, yeah, 6. Because question D part 1 is an evaluation question. And D part 2 as well. 6 marks experiment, 6 marks calculation, 2 marks evaluation question. And that's just question 2 of our exam paper. So after this, we will have a separate video on the tutorial for how to calculate the enthalpy change for this paper. Unfortunately, this paper was given to our lower 6 students, and they have only just started their semester, so they will have no prior knowledge of enthalpy change. Some of them may be able to infer Q equals mc delta T from O-level content, but the actual calculation for enthalpy change and even a Hess cycle will be totally new to them. So this practical is not recommended for fresh students, and if you are doing this practical with a fresh batch of students, you can probably avoid going through the calculations for this. I personally am going to just grade the rest of the paper with a new total. Instead of 40, it will be about 6 points less, yeah, or maybe 8 points less. So out of 32 instead. Thank you very much for watching this video. I hope it was helpful. If you have any questions, please leave them in the comments below. Thank you very much. Have a nice day.